we're focusing today on the electrification of fleet, and we're really pleased today to have Brendan McEwen with us from Dunsky. Unfortunately, Maddie wasn't able to join us today. She's under the weather, and so Brendan's agreed to take her slides and take the lion's share of the presentation. So thank you, Brendan, for doing that. Brendan's been doing all sorts of things from policy to planning and consulting in sustainability and such for a number of years, more than 17 now. And he's going to come to us and speak to us on fleet electrification. So I'm ready now, Brendan, for you to take over the reins, and I'll drop into the background and look forward to listening to what you have to say.
All right. Well, thanks so much, Andrew, and thanks to everyone who's joined today. It's an honor to get to be here with you. And again, Maddie sends her regrets, and hopefully I'll be able to adequately fill her shoes as part of this. So as Andrew noted, I'm a managing consultant at Dunsky, and I've worked in policy, program design, and working with corporate and other sectors in decarbonizing their operations for the last 17 years or so, including a variety of projects relating to decarbonizing fleets. Maddie leads Dunsky's fleet decarbonization practices, and we're really pleased to get to share some thoughts on what are the key processes, challenges, and opportunities to support fleet electrification and decarbonization. So just a little bit about Dunsky. We have been in business for getting close to 20 years. We've got over 50 professionals all across Canada, and a wide range of projects providing both detailed analysis and modeling, as well as strategy development for buildings, industry, energy, and notably the mobility sectors. Mobility has really been a rapidly growing and key focus of our work, particularly in the past, I'd say 6 or 7 years. In that time, Dunsky's had more than 150 EV-related projects for major clients all across the country, as well as many south of the border as well. So what I want to share with you today is 3 broad things. Firstly, I'll just provide a little bit of an EV 101 to give a sense of how rapidly the transition to electric vehicles is taking place. I'll then speak to the broad process to develop a fleet electrification roadmap, and then share a little bit about how to think about planning EV charging infrastructure. I think there's, for this audience, particularly sort of ripe conversation, fruitful conversation to be had around thinking about charging infrastructure, because ideally we're going to plan our EV charging infrastructure in concert with other initiatives to both save electrical capacity, as well as conversely increase electrical capacity by decarbonizing through electrification other building loads. And we can add the most value by thinking holistically about what are going to be the best electrical sorts of design approaches at facilities where EVs charge, but where other things happen, where people work, people recreate, and that sort of thing. So I'll say a little bit more about that charging infrastructure opportunity as well. So in terms of, a really high level overview of what's happening in the EV space, broadly, battery prices have decreased by an order of magnitude in the last 10 years, and by about, I think, around 2 to 3 orders of magnitude in the last 30 years. And this trend is basically only continuing as there's increased scale and learning by doing. So all the forecasts are that over the medium to longer term, battery prices get incrementally lower as major manufacturers learn how to do this more cost effectively. What that means is that while historically there's been a price premium to electric vehicles, that's going away. And today we're basically at about cost parity for total cost of ownership and even upfront purchases for some vehicles. And that's just going to accelerate over the course of this decade, where we're going to have increasingly better performance from a total cost of ownership perspective compared to conventional internal combustion vehicles. And actually the first costs, the capital cost to purchase a vehicle, are going to drop below that for internal combustion vehicles. So this graphic is from the International Council on Clean Transportation. They're one of the most prominent, well-respected entities doing forecasts of this nature in the space, although you're seeing a similar story from pretty much every non-biased, non-affiliated analyst in this area, saying that we're going to see ongoing declines in battery prices through those sorts of learning effects. And then we are moving to a point where sometime in the next 3 or 4 years, and it ranges a little bit depending on the types of vehicles we're talking about, but we get to the point where the upfront costs for a pure battery electric vehicle are going to be the same and subsequently less than for conventional vehicles. So you see that here with battery electric vehicle BEVs with 250 miles of range, 200 miles of range, and 150 miles of range in these declining lines here. And then also that light pink at the top is a plug-in hybrid electric, which doesn't have the same types of cost declines because you've got two drivetrain technologies, both internal combustion as well as EVs simultaneously. So you don't save money by eliminating that internal combustion drivetrain. And also you've got a smaller battery. So the impacts of those battery cost declines aren't as significant. And in the light brown here, conventional. So bottom line is EVs are becoming more cost competitive, and they're going to be towards the end of this decade. If you do have the option to get an EV and to charge it somewhere, really the logical economic thing to do. Accordingly, EV sales are rising. So don't know why we only have up to 2021 here, but this is the same broad pattern up to Q2 2023, where we've had accelerating exponential growth in EV sales over time. And we've also got policy that's driving the transition. So the federal government is going to be adopting requirements that all new vehicles need to be zero emissions. So practically that means plug-in electric vehicles by 2035, and have interim targets of 50 or 60% by 2030 and 20 or 26% by 2026. So in addition to kind of the fundamental technological and economic drivers that are causing the whole industry to start investing in electric vehicles, we're also seeing policy backstop in Canada, as well as basically every other major advanced economy around the world that's driving this transition. And associated with that, we're seeing major commitments to electrify fleets from a wide range of different types of organizations, from all levels of government to corporate sectors, utilities, and others. And what folks that are responsible to manage fleets are asking themselves is, what is this transition going to entail? What are going to be the potential costs as well as potential benefits to how we operate our businesses? What kinds of timeframes should we be planning and committing to make this transition to mainly electric fleets, as well as other types of low carbon drivetrains too over time? And how much is this going to reduce emissions? What can we forecast as emissions reductions? And we're starting to see not just those sorts of commitments being made, but actually vehicles on the ground of a wide range of different types. So the transition is certainly most advanced amongst passenger vehicles. There's a variety of models that are out there and available. There are still challenges to get new types of vehicles of any sort, and there's definitely huge demand for EVs. So there are, in the next few years, going to be ongoing challenges for fleets, especially for smaller fleets, to be able to secure all the vehicles they want. But there's a wide range of models that are available in the light duty cars and trucks sort of range. And we've also seen a growing amount of off-road vehicles, low-speed vehicles, as well as medium and heavy-duty vehicles for a wide range of different types of fleets start to be available. And these are going to be increasingly available in the coming years so that we can meet most different types of vehicle needs through battery electric. Okay, so that's a high-level synopsis of the context that we're facing. And I want to talk about the process and best practices to develop a fleet electrification and decarbonization roadmap. So the key steps are firstly to understand how your fleet is used, what the needs of those vehicle operators are, what you need vehicles to be able to do for you. As part of that, we need to understand our inputs into our models and what key assumptions are. So things like how long vehicles will be able to be at a given location to recharge, how far we need these vehicles to be able to go over the course of the day to the maximum extent, and other information like that. I'll speak more to those types of key inputs and assumptions momentarily. With that information, we can determine what the optional time into the future will be to schedule for each different asset in a fleet, when that ought to be replaced with an EV or another type of vehicle. And then for those electric vehicles, we need to understand how what kinds of charging infrastructure do we need in order to be able to provide for everything that vehicle is going to be able to do. And understanding those things, both what we need in the charging infrastructure side of things, as well as what's going to happen from our vehicle turnover side. We understand the total costs of the transition and what makes sense from a life cycle cost basis, and understand the emissions reductions potential of this as well. So I'll walk through all these different components in turn. Firstly, we understand what vehicles in your fleets are doing. So we get an inventory of the range of different types of vehicles that will be in a fleet. We try to get as much detail as possible, and we're categorizing this based on, specific types of vehicles, as well as the duty cycles that they might be running under. So we'll understand those makes and models. We'll understand how far they need to go in a given day and where they're going to be parked. Do they have a regular home base at a depot? Are they regularly taken home by employees? Those sorts of questions. And then if there's any sorts of policies or best practices that the fleet operators are generally taking, that would be their de facto replacement schedule. Now, sometimes it does make sense to pursue early retirement and, sell these things into the used market before they reach your thresholds. But we do like to understand with the fleets we're working with, what's kind of the business as usual set of assumptions to understand when those would more naturally retire out of your fleet and you would need to be making a replacement. So we get that type of information for all the assets in the fleet. We determine how those vehicles are going to be used. So how far do they drive on average and on the peak usage day? How many stops do they need to make and where? Is there ever any call for on-the-go charging infrastructure? Are they spending a huge amount of time idling? How much time do they have not in use? That impacts what kinds of charging infrastructure we have. Basically, how fast we're going to need charging to be provided to the vehicle. And related to that is how many shifts are vehicles performing per day. So these are the types of questions that we're asking. There's a range of different ways that you get this sort of information. Sometimes vehicles have telematics data. They could have companies like Geotab already working with them, and we can get detailed information on the length of dwell time and in a particular location, how long they're spending at home base, detailed understandings of what their average use and what their peak daily driving would be, and how that might vary seasonally and other sorts of factors, how much fuel they're using in the peak day, as well as on average over time. Sometimes you need to make reasonable conservative assumptions of those types of things through interviews with fleet operators and those that use these vehicles on a daily basis, and understand both how that's done historically as well as how operations might change into the future. So in doing this for dozens of clients, we've used both those types of methods, and oftentimes it's kind of triangulating between the two to determine, all right, what's our sort of conservative design duty cycle for the vehicle. And that includes what we need that vehicle to be able to do, towing capacity, other things like that. And then there's a variety of different types of data points that get into the financial analysis that we're going to do on the business case to turn over a fleet. So we try to get historical information on fuel costs, on other types of vehicle costs like operations and maintenance schedules. We understand for a particular jurisdiction what's the carbon price that it's likely going to face moving forward, as well as what are reasonable assumptions around what are the fuel costs going to be in that jurisdiction. Obviously, like, predicting fuel costs is pretty challenging, but this is something we do regularly for all our projects. So we've got, I think, decent sort of ways to estimate that, as well as methodologies where we can help build nested contingent decision making depending on how these types of things are evolving over time. We understand if there's been any targets that have been set by an organization for decarbonization and electrification of its assets. So are you working with a university that wants to be carbon neutral by 2030? Has the corporation made any of these types of decarbonization commitments? These are all really important questions that are also going to be, of course, key drivers on what your fleet plan is going to be. I spoke to considerations we have around replacement timelines for different vehicles. So when would vehicles naturally age out and trigger a time when you're acquiring a new vehicle for use in that fleet? And a really key thing that we provide, I think, a lot of value at is understanding when EV models will be available for different types of vehicles. So if you're replacing a fleet full of sedans, it's pretty obvious. They're available today. There can be a little bit of wait times. Like, EVs are very popular, but we know that there's those sorts of vehicles available. There's increasingly, and it's changing really rapidly, vehicles of all types available. So we've got increasingly electric dump trucks that are going to be available. Even electric fire trucks are starting to come to the market. Step vans have an awful lot of options today, but it is harder to get your hands on those types of vehicles, and it depends on different types of factors. So we make sort of informed estimates about the range of time periods in which different types of vehicles might be available for different sorts of fleets, and might have the specifications that can meet the needed duty cycles for how those fleets are going to operate. And that's, where something I think you want to attend closely to, and something that, frankly, I think Dunsky does a good job of, is good or better than anyone that's out there working on this, is having reasonable sorts of estimates of when different options are going to become available for different types of fleets, in terms, again, of those medium and heavy duty vehicles and other sorts of applications. And then with that type of information, you optimize a total cost of ownership estimate for what's going to provide the best value for an organization as it transitions its fleet, as well as take into account what types of commitments have been made. So the tool that we've developed, eFleet, is going to estimate, based on those life cycle cost factors, what's the optimal replacement year when it's going to be least costly for an organization to replace its fleet, when it's going to make the most, or replace a particular asset in its fleet. So when it's going to make the most sense to replace that vehicle, incur the capital costs, but then reap the subsequent operating savings that can occur from the transition to electric. Based on that estimate of that factor for of what the optimal replacement year for every asset in a fleet is, we then put together a optimal replacement schedule for all the vehicles that are in the fleet. So this is an example of, an actual fleet that we worked with, which was noting when different types of vehicles in their fleet would be replaced in what year. So that's an example of this showing, okay, here's our cars that are in that fleet, mainly getting replaced before 2024. Here's also the SUVs getting replaced before that date. And then we're going to do increasing truck replacements starting in 2025 as those are more available, and step vans mainly beginning in 2025, although some piloting of that in 2022 to 2024. And just examples of that same sort of thing for other types of fleets. We've done this with vehicles where we've got medium duty class 4, class 5, as well as heavy duty class 8 and fire trucks in a municipal fleet, and understanding when those things are likely to become available and making those transitions at that time. So you can see that availability, best estimate is going to be that it's more available, and it's going to make sense to start adopting this in the latter part of the 2020s for those larger heavy duty vehicles. Still really important to start planning today, especially as we'll chat about momentarily, start thinking about the charging infrastructure that those types of vehicles are going to require today, because bigger vehicles predictably require more power, and that can have a greater likelihood of needing electrical service upgrades, which may or may not be easy for utilities to provide. So getting back to sort of the fleet process, we then calculate what are going to be the costs, both under kind of business as usual, no electrification scenario, or we can define other sorts of business as usual scenarios with clients too, of course, if they want to reflect that, yeah, going forward, it's probably makes sense that many of these vehicles go electric, but maybe we're trying to accelerate that process to meet stretch emissions reduction goals. So we can work with our clients to define what the BAU will be. But we work out what are going to be the capital costs under the fleet electrification plan, as well as a BAU scenario. And then we think, well, what are going to be your ongoing maintenance costs associated with that? And EVs will tend to have lower maintenance costs than your business as usual vehicles may have, which would be more internal combustion. And likewise, EVs have much lower costs to use electricity to refuel them compared to internal combustion vehicles using gasoline or diesel. So it really varies depending on your electricity rate. But let's say here in BC on a general service rate, you might be looking at the equivalent of about 20 cents to 30 cents a liter gasoline to charge up an EV. It can be a lot less when you take advantage of sort of smart charging opportunities to charge when costs are least expensive on utility grids. For the low cost overnight rates that we see in Ontario, it can be as low as the equivalent of 10 cents a liter gasoline or even less. So there's significant fuel savings that can be realized through this transition. So with those types of factors, we then determine what's the life cycle performance. So this shows, an annual discounted cash flow here in the dark bars, and then a cumulative cash flow is this line, and you can work out, the appropriate sorts of capital and operational budgeting that you'd be doing over time, as well as, of course, what's your internal rate of return, what's your net present value, those key elements that are necessary to help develop the business case. And likewise, our models are able to work in a couple different scenarios that might build in uncertainty around, hey, when are different EV models going to be available? How much are they going to cost? And let you make sort of contingent decisions as part of your plan and have associated financial performance with those under different assumptions. In addition to the life cycle costs, we're of course quantifying emissions reductions. So here's an example of that in a sort of business as usual, where we still had a lot of internal combustion vehicles in the fleet. We'd have steady, slightly growing GHG emissions, whereas as we go towards electrification, it's reducing emissions 60% below baseline by 2030. And I'll round out the conversation around how to plan a fleet decarbonization strategy with a couple of points of what we've learned. Firstly, it's abundantly clear that cost-effective fleet electrification for a wide range of vehicles is going to be possible in the next decade. Secondly, in significant part because of the need for charging infrastructure, which we'll talk about momentarily, return to base operations are particularly well suited to electrification in the near term. So if you've got a facility where certain vehicles are parking every night, and that depends, even if it's light duty passenger vehicle, or if it's medium duty step vans, if it's medium duty municipal vehicles, if they're going back to a Home Depot, that's going to present the best opportunities for electrification in the near term. We do find that there is still a role for plug-in hybrid EVs sometimes. They can sometimes achieve appropriate emissions reductions while allowing for edge cases where, let's say, vehicles sometimes need to be driven very long ways and there might not be adequate public charging infrastructure that you can depend on. So they can be a useful medium ground in some applications, although we're usually finding that for most applications, pure battery electric is going to be the lower cost and more advisable strategy. And lastly, all across the country, all across North America, really anywhere in the world, the GHG emissions reductions are very significant. And that's just going to be the truth more so as grids decarbonize. So like any form of electrification that's implementing efficient equipment, we are seeing a benefit today at current grid intensities, and that only improves over the life of the vehicle as grids increasingly decarbonize. There are definitely challenges. EV availability is relatively low compared to demand. We're in this kind of messy transition. There can be challenges getting hands on vehicles, especially for smaller fleets. There's, of course, resistance to change amongst some organizations. Involves changing the way we do things. There's legitimate sorts of challenges, of course, when you've got, let's say, people that are trained in maintenance for certain types of vehicles. There's going to need to be investment in training and understanding what are going to be processes to support maintenance for other types of vehicles. We have learned some things about how to best manage that transition, and we're keen to work with clients moving forward to develop even better strategies for how we can address those types of issues. As I'll speak to shortly, and as I imagine a lot of folks from AEECE are well aware, electrical upgrades can be an expensive as well as lengthy process and can be a spanner in the works for fleet electrification projects. So it's important to understand what are going to be those electrical impacts sooner than later, and be working with utilities and electrical consultants proactively to try to address those issues. Say more about that in just a second. Likewise, of course, there's issues around budgeting, perennial problem for sustainability projects. Capital and operating budgets can be developed somewhat separately, and it's not always easy to help make the case for a significant capital investment on the basis of future operational savings. So there's work that needs to be done to help organizations understand that opportunity, help them get access to financing if needed to make that happen, or other sorts of internal financing mechanisms. We help organizations that need it with those types of elements of the transition. And finally, as I've alluded to, conditions change, plans change, the availability of vehicles and sort of the contingency of commitments that you need to make can be variable, and clients need an element of flexibility. And likewise, organizations' capacity to incur capital expenses or other sorts of things can be variable. So we try to help develop plans that recognize that and provide solutions so that under the range of possible potential futures, we can realize what's going to be, best meeting the goals of the organization and most expediently getting decarbonization done, given those limitations. And finally, just to notice, we've been alluding to, it's early days, but there are a wide array of different types of vehicles that are increasingly available. So this is a refuse truck that's out there in New York City operating today. These are electric Zambonis that are in operation in Calgary, Toronto, Vancouver. They've got electric fire trucks on order that are going to be delivered in, I believe, the coming year. And there's a really rapidly growing range of low-speed vehicles that can both result in sometimes significant reductions in capital costs, as well as just major operating cost savings, provided that can meet the duty cycle of vehicles. So we see like a growing range of options out there. It's frankly, some fleets had early experience with some of these vehicles and felt, they really, they're a pain to work with. They weren't serving our needs, and they were generation one. And, in subsequent generations, their utility has improved, and they will probably continue to improve in the future as more options are available. So I'd say actually that's one of the biggest challenges, is getting folks that are out there in operations that are used to doing certain things open to the idea of driving something that doesn't look like the big pickup truck that they had previously, and seeing, okay, can we make other types of things? Can it work for us? We obviously need the vehicles to totally suit our workflow. We can't be interrupting operations, but there also are opportunities for these vehicle right sizing as well as fleet right sizing. So we're alive to that. We try to help clients understand that, and we try to determine whether that's going to be an option in particular fleets. Okay, I'll spend maybe 5 or 10 minutes here at the end speaking about charging infrastructure planning. So there's some key considerations for when we're considering how charging infrastructure can meet our needs and what sorts of infrastructure we want to plan at facilities. Firstly, we want to understand how many chargers there's going to be to serve a given number of vehicles. Probably the baseline assumption you want to make, particularly for return to base fleets, is that you're going to have one charging port for each vehicle. If you're trying to have a lower number of ports serving a greater number of vehicles, then you're going to need sort of operational coordination and planning when vehicles are going to charge between multiple different vehicles, and potentially moving vehicles off infrastructure. That can work for some fleets, but oftentimes the relatively modest capital cost of just putting in like a charger at all your parking spaces isn't going to be enough to like dissuade you from just keeping it simple and doing this one-to-one relationship. So we think about that. Then based on how many chargers per vehicles we have, we understand and the duty cycles of those vehicles. We then determine, well, what's the charging speed that vehicles need to meet their kind of maximum potential duty cycle. So this relates to how much downtime each vehicle has between shifts. Like, is it parked there for 12 or more hours overnight, or is it only going to have about 4 hours to recharge before it needs to be used? And in your sort of maximum case duty cycle, how much is the battery going to deplete? How much energy are we going to need in a given day? So we make reasonable assumptions around these sorts of things, trying to take a conservative view, but then determine what's the sort of minimal charging speed per vehicle that we can get away with, depending on our charging strategy. Because faster charging speed, greater electrical capacity to provide charging is generally going to increase costs. It's not exactly linear. Some things are lumpy. There can be big step changes, but it is a pretty steady relationship. More charging speed for more vehicles is going to mean more electrical capacity, which means cost. So once we figure out what that charging speed for each individual asset we need to design for is going to be, that then dictates what are opportunities to use power sharing. So power sharing involves sharing electrical capacity across a given circuit. So it could be a branch circuit. Sharing could be done at a panel scale or sort of coordinated at a facility scale. It uses what are called EV energy management systems in the Canadian Electrical Code. And the value of this kind of power sharing is that it minimizes how much electrical capacity that's going to be needed to be designed for to be compliant with the electrical code, to provide an adequate amount of power to those vehicles. So for vehicles that have relatively low daily energy requirements, like let's say an average amount of driving for light duty vehicles, like equivalent to, maybe 25,000 kilometers a year, and that's going to be parked for significant periods of times, like let's say overnight, you can get away with pretty significant power sharing, maybe having like 4 vehicles sharing a 40 amp circuit, and everyone is still going to get an adequate amount of power for their next day's driving, and your costs of those electrical renovations that you need to do to a facility are going to be significantly lower. So for those vehicles that have lower energy requirements, longer charging periods, this is an important thing to be considering. Now, as we get into medium and heavy duty vehicles that are going long distances, certainly there's a certain amount of load management that is valuable, but there is going to be a lot more power that needs to be provided to each vehicle. The benefit of this is especially that you can avoid the need for electrical capacity upgrades. Now, there's just no way you're going to be able to power certain types of vehicles without getting a new service from a utility, but sometimes that can be avoided, and there can be real value to doing that. So when we think about electrical capacity, we of course want to understand how much power vehicles are going to need and what are the opportunities to use EV energy management for power sharing. But we also want to understand what else is being planned at a given facility. Like let's say it's a municipal city hall. Are you also going to be electrifying a lot of other loads? Are you also going to be wanting to provide your employees and not just your fleet with EV charging, or members of the public with EV charging? When are all these things going to happen? And what does that mean for how the electrical facilities at these the electrical equipment at these facilities is going to need to evolve over time? So it's that kind of holistic thinking and merging both an understanding of what's happening with fleet and other EV charging needs at different types of facilities, as well as what's happening to decarbonize buildings, that I think is really at the cutting edge for all of our built environment, when we think of not just places where fleet charge, but really all kinds of applications, workplaces, multifamily buildings. This is the key question to be asking ourselves, is how can we anticipate the electrification of nearly everything, building systems, space heat, hot water, as well as EVs at scale, and how electrical systems will need to evolve. And even thinking about things like, okay, are we going to do a lot of solar PV on site? Are we going to do battery storage on site that can help address electrical impacts? and avoid or optimize service upgrades from the utility systems. So we encourage and try to help clients think about those types of broader facility plans. It's not necessarily easy, but we think it's an important part to at least bake into your fleet plans. And we help them understand the potential for vehicle to charger ratios, what kinds of charger speeds it makes sense to have, and what's then going to be the opportunities for things like power sharing. So that's, a fair bit of detail. To take a step back, broadly, there's 3 different types of charging. There's level 1, which is like a 120 volt, not usually used for fleets. Level 2 is used for a lot of passenger vehicles and some medium duty fleets. That's 208 or 240 volt, anywhere between 12 and 80 amps, which provides increasing amount of power and charging speed. And oftentimes you see varying degrees of power sharing used for that type of application. And then DC fast charging is quite fast. You would usually use this for either quickly charging up a light duty vehicle, let's say half an hour, an hour or so, as well as for home base types of applications for the larger vehicles, let's say Class 8, like flatbed trucks and other things that have pretty aggressive duty cycles. You might need to have DC fast charging, even if it's charging for like a 6 or 8 hour period during the day at its home base. I mentioned power sharing, so to say a little bit more about that, that's accomplished through EV energy management systems. So EVMS monitor and control loads, and their advantage is that they can reduce the electrical capacity needed in a building. So it's kind of illustrated by this diagram at the bottom. Basically, if you've got one vehicle here that's plugged into this 40 amp circuit, it can take the full capacity of that circuit and charge relatively quickly. But if multiple vehicles are plugged in, the charging infrastructure, the charging stations communicate with each other across some kind of network, maybe it's cellular or Wi-Fi or something, and throttle down consumption so that they don't exceed the capacity of the circuit. And that can make much more efficient use of limited electrical capacity on site. As I've alluded to, it's well suited to light duty vehicles as well as medium duty vehicles with lower daily VKT and long charging windows. I won't go into too much detail on this, but basically there's different sorts of broad electrical configurations and EV energy management strategies that can be used. So there's sharing across a branch circuit, but there's also sharing at the panel level, and even coordinating all charging by measuring in real time how much power is instantaneously being used, how much current is instantaneously being delivered on the main service to the building, and making sure by controlling the EV loads that services limit isn't approached. And the takeaway is it can save significant amounts of money. So a lot of times electrical designers without much familiarity with EV systems, which still probably describes, a lot of the folks that are out there, although it is changing rapidly. People are building a lot of facility with this kind of stuff. Think we just need dedicated 40 amp circuits to each EV. When you do that at scale, it can be pretty expensive. So in this case, it was a multifamily building, what it costs to provide all parking spaces with EV charging. It was going to be $5,500 or more potentially with service upgrades per parking space. So pretty expensive, but there's totally viable load control for configurations that would get you a lot lower cost per parking space. So we want to understand what's the electrical capacity we've got to work with. What are the EVs going to require? What is their fleet electrification going to require? And then also, how is other building systems electrification and efficiency initiatives, as well as other EV charging, going to impact that limited capacity? So to summarize the key takeaways, it makes sense once you've done the initial sort of assessment and determined, are we possibly going to need electrical service upgrades, to talk to utilities early on in the process. Some fleets are getting tripped up by waiting too late to mention to utilities that they're going to need a service upgrade. I'd say this is particularly an issue, although it's an issue for all types of fleets, but particularly for medium and heavy duty vehicles, goods movement, as well as like medium and heavy duty that's used at, let's say, municipal or utility works yards, that type of thing, or any level of government really. That can be something that delays projects. It makes sense to invest in a thorough charging infrastructure strategy that also considers other sorts of uses, energy uses that are, and how capital plans will evolve at sites. And you want to be looking to minimize your electrical demand if at all possible through power sharing. So hopefully that's all useful sort of insight into, I guess, our process to support fleets with electrification, and what are some of the key considerations we make at facilities. This is Maddie and I's contact info. Really looking forward to any sorts of questions and further discussion here, but thanks very much for your time.
That's awesome, Brendan. I'm still watching the questions. Nothing's popped up, but I had a few actually that I kind of took a note of as you were chatting through the presentation.
Yeah,
so the first question that I have is really related to what you guys are seeing beyond the client responsibility. So like I know you're working, across the country. You're working with all sorts of different clients, be they public or private, and I'm sure that you're starting to see the trends from a fleet electrification perspective.
Yeah.
What do you think the burning issue is, like, beyond continuing to ensure that each of our buildings is as efficient as possible to free up as much built capacity as we can? Like, what are the utilities going to need to do to pivot to allow the adoption curves that you guys are looking to see?
Yeah, what a great question, and there's a lot there. When you first were asking the question, because of course we do this fleet work, we also keep our finger on the pulse of policy and help all sorts of government clients and other types of clients think about climate policy and how they can drive the transition faster. So today we've got the federal government having committed that there's going to be an EV sales mandate for light duty vehicles. We've also got increasingly provincial government saying, hey, there's going to be sales requirements for other types of vehicles, medium and heavy duty, which encompass trucks, buses, all types of medium and heavy duty fleets, that OEMs, like the manufacturers of these vehicles, are going to have to meet a higher and higher quota of all their vehicles until eventually all of those need to be all electric as well. There's potential that happens at a national scale. It's definitely happening at a provincial and state scale, and that's also going to change the market for those types of vehicles. It might just shift OEMs faster than they otherwise would into saying, okay, we're going to focus exclusively on electric for those types of vehicles. So that's driving change. And then on the policy side of things, another key thing that's happening is not just sales mandates, but actually fleet composition mandates. So California is the most out ahead on this, but most of more progressive jurisdictions across North America, there's about 15, 17 states that have all committed. They're just going to follow in lockstep with what California does on this, as well as, we tend to see several provinces in Canada do the same, say they would adopt similar types of regulations. So they're starting to say X proportion of fleets, for fleets above a certain size, and it varies on the type, need to be electric by X date. So bus fleets have very rapid decarbonization schedules that have been set through those types of policies. Trucking fleets of different types, like urban delivery, have pretty aggressive schedules. Drayage have pretty aggressive schedules, and even other types of heavy-duty goods movement are going to have a greater and greater proportion of their fleet be zero emissions. So that kind of thing is also going to drive the transition. In terms of utilities, like, it is a significant challenge and also opportunity for utilities to be able to provide this type of power. I think the transition to EVs broadly is going to be very good for utilities and good for ratepayers. You're selling more electrons across like much more electrons to a variety of customers. And so if you definitely are going to need to expand distribution systems and bring on new like power generation capacity and transmission to a certain extent, well, to a significant extent. But you're also going to be selling more kilowatt hours. There's an opportunity there to help reduce pressures on rates going up because you're selling more kilowatt hours. But conversely, if you're not charging these vehicles in optimal ways that's good for the grid, it can create real problems, and you're going to have like needs for distribution system upgrades sooner than expected. So I'd say all utilities are rapidly becoming really aware of this and trying to think about how to solve the problem. There's a variety that are making major moves in this direction. I think we're going to see in the future broadly much more emphasis on dynamic utility rates that better reflect the real-time price of selling power. So today, with general service rates, a great comparison is like the way we price utility power, electricity, is kind of like if you went to the grocery store and just got to throw anything that you want in your grocery cart, and they just weigh your cart at the end and charge you on a volumetric weight basis. It's kind of the same way with kilowatt hours. Right now, we charge a certain amount per kilowatt hour and a certain amount per demand, but it doesn't reflect that at certain times, it's so much more expensive, orders of magnitude more expensive to provide that kilowatt hour and to provide that amount of demand than at other times. So the lowest hanging fruit, and we see more and more utilities seriously considering how to do this, is to have dynamic utility rates that better reflect the real-time cost of power. We're also seeing an awful lot of utilities that are interested in working with entities that are controlling a lot of EV loads, notably fleets, to see how they can directly signal to those fleets when there's a demand response event, and how to control that type of have some ability to control charging while still making sure that those fleets are going to be able to get what they need to do done or be compensated handsomely for times when there are interruptions to their services. So that type of effort, to either through like demand response, real-time signaling, or at least getting sort of basic price signals right, I think is an awful lot of what needs to happen. And then there is just going to need to be more proactive planning of how distribution grids, transmission grids, and power generation need to evolve over time. There's been a lot of interesting analysis, let's say looking at industrial areas and say, hey, as total cost of ownership of these larger goods moving vehicle switches, we might see really rapid growth in demand for power on these industrial substations and feeders serving those neighborhoods. So what do we need to do from a planning perspective to be able to deploy infrastructure in time to meet that? That's a big part of why I say proactive engagement with utilities and making sure they understand as early as possible what fleets are considering, particularly when it's with medium and heavy duty vehicles, commercial sorts of operations is really important. So hopefully, Andrew, that's a useful snapshot of some of the key things that utilities need to do to respond to this move towards electrification and are doing, as well as what some of the policy drivers will be that are going to make this transition happen even faster, really, than I was alluding to there at the outset.
Yeah, it is. It's great insight, and I guess one of the reasons why I asked the question is because I get concerned sometimes when we're looking at large transformations like this, electrification pushes, that you end up falling into this tendency to have to choose this or that, whether you're gonna electrify your fleet and go EV, or whether you're going to not, because you're limited with your availability of power. So the one thing that I found very interesting in your presentation was the strategies for designers to throw a level of control in, and how the code allows for that, energy management control type systems. I wonder, by extension, like, do you see that becoming like a code requirement as opposed to just flexibility within the code to implement a control strategy like that for charging?
I'm not sure if I see it becoming a code requirement. We've been fairly involved in this, and I haven't seen anyone propose like thou shalt, thou must be able to do that type of flexibility. Although I wouldn't say there's no chance that happens. But I do think it's largely about enabling through electrical codes the ability to take advantage of all different types of energy management systems, and then making sure that the right incentives for the building owners and the fleet operators and the operators of those facilities is there to make use of those, and that designers understand that, and manufacturers of charging infrastructure and whatnot understand all those opportunities. So there's definitely an opportunity there. This is going to be a big challenge and also a huge opportunity to coordinate electrification of transportation as well as building systems. Sometimes there's going to be no way around it. We're going to have a new utility service. And, one thing I didn't mention that some utilities are starting to do is look at how they can update, let's say, the extension costs that are in their utility tariffs to make it more predictable, so that you at least know how much it's going to cost. Right now in Canada, like an awful lot of utilities, if you do need a service extension or a new service, what you do is you go to them, you say, hey, we're planning to add this amount of load, how much it's going to cost. And they'll look at what that does to their system. And if it doesn't impact things very much, you just need a service to the property, they might say, well, this will cost $10,000 or $20,000. If it does trigger a feeder upgrade or a substation upgrade, they might come to you and say, you're going to incur a cost on the system of $3 million and you need to pay that whole thing. And that kills the project. Now, I'm increasingly seeing some utilities and utility regulators say, this is, and provinces say, this is a challenge to electrification. We've got a lot of complaints from, let's say, land developers and others that this is a major hindrance to, firstly adding things like housing, but also to electrification. Can you look into what your extension fee policies are and put together a regime that's going to be more predictable? So I think there might be a move towards having more just sort of standard predictable costs that like distribute those total system upgrade costs across all users, and being it less like what is that particular user incurring there. That's one possibility that I see increasing appetite for. Another thing is I imagine that when there is that impact happening, there might increasingly be utility programs that say, how can we work with developments in that area to get local demand response that's going to be reliable enough that we can avoid those types of upgrades. Now, a lot of the time we are just going to have to eat it, incur those costs. It's ultimately going to be made up by just the fact that we're going to be selling more kilowatt hours. And, from the climate imperative, it's something we have to do. But there's also going to be an awful lot of value opened up from energy engineers who understand those dynamics, understand how we can get dependable demand response from both EVs as well as other sorts of building systems to be able to defer some of those distribution cost upgrades. I'll stop there. Hopefully that's good food for thought. I think people that are in your organization's role are just going to be so valuable in terms of being able to help make that opportunity a reality.
Wow, that's really good. I find it really insightful that you have such a finger on a pulse of how policy is built, because not all of us do. So thanks for that insight. A bit of a pivot, and I don't know how long this answer will be, but I'm curious. You mentioned briefly in the presentation about kind of the difference between fleet charging infrastructure and publicly accessible charging infrastructure. And
yeah.
I guess I'm curious from your perspective and from your experience, what organizations are doing to make best use of the installed infrastructure. For instance, fleets often have the opportunity to charge kind of after hours in the evenings. and perhaps folks that are attending buildings as a place of business or place of work might want to charge during the day. Like, what are you seeing your clients doing to balance between those two users with that infrastructure?
Yeah, it's a great opportunity. And, once you have that infrastructure in there, which refers both to the electrical infrastructure as well as just the parking space, space, especially in our cities, is increasingly at a premium. We use a lot of space for parking cars and we can use it more efficiently. So sometimes it's just that impact that actually dwarfs sort of the economic opportunity of making better use of the electrical infrastructure. It's making better use of that limited space. But if you've got a parking space with an EV charger there, and you're charging a fleet, let's say overnight, and that fleet goes out and about during the day, there's absolutely an opportunity to provide workplace charging in many instances, or publicly accessible charging. And we're seeing progressive jurisdictions do just that. So we're working with a couple of cities right now that have parking on site that's historically been used kind of as scramble parking, either for fleet vehicles or for employees when they come to the site. And they're thinking, okay, well, can we reorganize our parking policies, get like the facilities and parking folks involved, and just say these spaces are dedicated for fleet and only fleet between 5 p.m. and 8 a.m. But in those other times, you as a employee at the site or visitor to the site can come here and plug in and charge. I didn't speak too much about like charging service providers, but basically these charging systems, many of them are networked. They can communicate across a network and they come with a bit of intelligence. So you can have the system easily programmed to say, okay, I have a fleet vehicle. I'm going to use my fleet's vehicle's key fob and fob in, and it'll start the charging session. And then when you leave in the morning, and let's say an employee or a member of the public comes, they might have a card that they can swipe and it'll start charging and be allowed to start charging because it's within designated times when they're allowed to do that. And they'll be able to do that, or most of these systems now have credit card payment on them as well, and we're moving towards the future. It'll be a couple of years, but a lot of them are going towards plug and charge technology, where it's actually just the car communicating with the charging station, and the car's got an identifier. The charging station knows these types of vehicles are allowed, or these types will have this sort of price scheme applied to them or not. So you can charge user fees to members of the public or to folks who are employees at your organization. You can give a break on user fees to provide a little bit of a perk for the employees of the organization. You can keep track of what the costs are, and send like individual departments at a city or another organization bill for the amount of electricity that they're using over time. And as we move towards real-time pricing of electricity, we can reflect that there's lower costs at different hours of the day and charge people appropriately. Finally, you can also use all that infrastructure to say, hey, we're driving vehicles and that's displacing gas vehicles. And under Canada's clean fuel regulation and BC's low carbon fuel requirement, there's going to be a real opportunity for organizations to generate revenue by selling fuel wholesalers like the likes of Chevron or Shell or whoever, Petrocan, sell them credits for the carbon attributes of that refueling. So the Petrocan and Shell and everyone are going to need to be purchasing these sorts of credits in order to be in compliance with the clean fuel regulations. And that's actually a revenue opportunity for organizations that host charging infrastructure. So bottom line is you can make this additional revenue stream, which we've costed into some of our fleet assessments, both from your fleet's charging as well as from any members of the public or employees that are coming and visiting your site. So huge opportunities there to make better use of your assets and also get that type of revenue. And I think as we explore that more, we're just seeing more and more value with that type of thing. And last thing I'll say is it is definitely an opportunity for real goodwill as you're doing that. It just does take some kind of cross-departmental coordination, which I'm sure resonates with folks on the call. That's always sometimes the trickiest bit.
Yeah, no kidding. Well, that's really interesting. I had no idea that was really, a piece of the pie. It never would have occurred to me. That's cool. And perhaps my last question, and and perhaps one that you wouldn't necessarily link directly to challenges or opportunities for EV charging, but we're on the way out of a pretty substantial society shift, from COVID.
Mm.
And I think many organizations are seeing occupancy in their buildings kind of like on the order of 30%.
Yeah.
People return to work on any given day, and I guess I'm curious, how has that, or has it played into fleet decisions? Is that one of the factors that your e-fleet tool is considering?
Yeah, I'd say we work with organizations to understand what their fleet looks like today, as well as to understand in the future, under different types of assumptions, what it might look like 5 or 10 years down the line. So we can help organizations think about opportunities to right size the vehicles. We can help them think about opportunities to right size the number of vehicles in their fleet. We can look at historical data, whether through telematics or interviews, and help advise on what would be the right kind of fleet composition. Those elements of things aren't 100% automated. There's a major component of, like, it gets down into strategy and just thinking about, okay, well, what can we do? How's the fleet going to look best in the future? And what does travel patterns behave like, especially in this new reality? It's not totally unautomated either. Like, we can help speed things up, but there is like an element of different applications being different. Different types of fleets are going to be impacted by COVID in really significantly different ways. So we more just want to best understand, our clients' needs around that, and then use eFleet. Like, a core, what it does is, once you know what vehicles you have today and what your future fleet composition is going to most look like, it's going to help us optimize and understand the financial impacts of when we make that transition to an electric or other type of vehicle for those different assets. But there is a significant component of things that happens even earlier around, again, right sizing the size of your fleet and what types of vehicles you've got in it. Last thing I'll notice, we haven't seen as much impact on, let's say, vehicle fleet, although it certainly happens in terms of, like, if these vehicles were home based at the workplace all the time versus are they oftentimes kept at employees' households. In let's say the professional sector, that's mainly happening, but there's fewer impacts on, let's say, vehicle fleet compared to, like, for central business districts, office worker parking demand and that sort of thing. That's where like much more of that kind of impact and just change in the land use economics is happening.
Cool.
Yeah.
Again, interesting. I know it was perhaps a little bit of a tangent to the primary conversation, but it's always nice when you have somebody on the phone who has some knowledge. It's always nice to tap into that. Listen, thanks so much for taking the time today and kind of sharing with the group what you've been seeing and the process that you guys use. I've been really looking forward to having Dunsky present for us, and you definitely reached the bar. You exceeded it. It was a great conversation, Brendan. I'm really glad that you made the time.
Oh, hey, thanks so much, Andrew. Thanks to all the folks that are on the call. We appreciate the opportunity, and we hope to, coordinate with some of you guys moving forward. And we appreciate all the great work you guys are doing out there to save megatons and gigatons. So yeah, let's keep it moving forward, and hopefully that's been a useful use of time for people. Appreciate it.
You bet. It takes a village in all ways.
Totally.
Thanks a lot again, Brendan. Have a wonderful rest of your day, and thanks everybody for tuning in to the webinar. And we'll post it up on YouTube for people to watch later on if they want to relive or revisit some of the things said. Excellent.
All right.
Have a good day.
Take care.
Okay, cheers.